So I'm just going to do, like I said, a couple of these odd problems from 6-3. Go ahead and write on your paper. Your assignment is the even ones.
Bless you, Jack. One more time.
And the odd ones are uploaded. Hey, good morning. The odd ones are uploaded for reference so that you have that many extra examples on Canvas. And like I said, this one's the only one that has the negative exponent, so I'm not going to use that as my example because it doesn't look exactly like any of the other ones. But as far as the steps go, it works the same. And that is, first, isolate the part that has the exponent. So I'm writing isolate exponent expression. So it may be a variable with an exponent and no parentheses, like how this looks at number 2. And it may be that you have something that does have parentheses, like number 5. This whole expression has parentheses. Number 6, there's parentheses. That whole group has an exponent. That's different from number 4, where only the x has the exponent. So the parentheses make a big difference. Pay attention if there's parentheses or not. Once I have the expression that contains the exponent isolated, then I raise to reciprocal power. So that means I flip my exponent upside down. It's a fraction. I flip my fraction upside down and raise it to that inverse power. You have to do that both sides of the equation. Don't forget to do the side that doesn't show an exponent. If you choose to add this to the equation on one side of the equal sign, then you have to do that on the other side as well. Just like if you divide on one side, you divide on the other side. Or if you add, then you have to add. Okay, that should then cancel the exponent. The exponent fraction will simplify out. Like if I have x to the 2/3 and then I raise that to the 3/2, one of our exponent properties is if you have something with an exponent and a second exponent, then you multiply these together. So this would simplify to x to the 2/3 times 3/2. 2/3 times 3/2 is 1. So that's why we do it like that. Then it eliminates the exponent. And it has fractions, and you're going to be okay. All right. Then you solve for the variable. And it's a good idea to check your work. The end. So, this is it. Yes?
So like on number 2, do we put, like do we times that by 2/3, or do we times 64 by 3/2? Because like you said, raise the reciprocal power, you're not only to the variable, or
Only the exponent.
okay. So we're not doing it like to both sides?
You do both sides. So, for example, one right under this, 27 equals p to the 3/4. If I follow these steps I just wrote, then the first thing I do is make sure that the part that has the exponent is isolated. So for number 3, It's already isolated. So step 1, we're good. Then I have p to the 3/4 power equals 27. And when I rewrote it, I wrote it with a little space there because I'm going to do something with this exponent. I need to flip the exponent and multiply. So I'm going to raise this to the 4/3 power. And with our exponent properties, that means I'm supposed to multiply the exponents together. Let me make that bigger. Okay. But I added this to the equation. It wasn't on there. Thank you. So since I did this, I have to make sure I do 27 to the 4/3 power also. So now what I have is p to the 3/4 times 4/3. That's p to the 1 power. That's just p. Okay, equals 27 to the 4/3. And that you can put in the calculator.
You get 81.
Shoot, I don't know. I don't have one of those calculators up here. Just a second, let me look. I'm going to go yes on that, but I should have grabbed a calculator first, y'all. Sorry. This is when you go grab yourself a calculator. Here, I have this calculator app. So if I do 27 and I use this caret here to raise, it's right over the 4 primary operations, the little rooftop, then that gives me an exponent, and I can put, aren't I doing 4/3? 4 divided by 3, then I get 81. 4/3 is 4 divided by 3. So yeah, it's 81. This is 27 to the 4th power, and then the cube root. So cube root, I can do the 4th power and I get a big giant number and then I do cube root, or I can do cube root and then do 4th power. So then I would get 3 to the 4th power. Or you can put it in the calculator and get 81. And I can plug this in and check. To check this, I want to know, is 81 to the 3/4 power equal to 27? So I can put that in the calculator. Is 81 to the 3/4 power, 3 divided by 4, yeah, it's 27. So you can plug it in and check yourself. Right? The end. Not that bad. It looks horrifying, but it's not that bad. Make sure that when you raise to the power on both sides of the equation, that you're flipping the exponent upside down. Be sure to flip fraction upside down. Here I had p to the 3/4. If I said, okay, that's 3/4, I'm going to do 3/4 on the other side. It doesn't work like that. That's not what we're doing. So make sure you flip it upside down. Okay. I have one right under this that has more going on. Number 5. Here I have -5 times this expression in parentheses. the whole group has this exponent. So I need to isolate this whole thing. This whole block has to get isolated. If you want to use our make it look simpler trick, so that then you know what to do next, you can. You could write this as, I'm going to write it the other way so that what it's equal to is on the right side. That's how I'm used to having it, is where my variable is on the left. So I'm going to write negative 5e, which is my expression I just highlighted, to the 3 over 2 equals negative 1715. You okay with that, if I do it like that? Yeah? Okay, so I can see really clearly now the exponent only goes to the expression because there's no parentheses anymore. So what I need to do first is divide by negative 5. So when I divide by negative 5, I get my expression, still to the 3 over 2 power, is equal to negative 17 over negative 5, whatever that is. Negative 1715. Is that what it is? Oh, heavens. Okay, negative 1715 divided by negative 5 is 343. Okay, so I'm going to replace the number on the right with 343. And then I need to put my expression back in because it's isolated now. So I'll rewrite this as parentheses x minus 12 to the 3 over 2 power equals 343. To remove the exponent, I raise this to the 2/3 power. So 343 goes to the 2/3 power. My exponents simplify and become 1, and I get x minus 12 with no exponent on the left. And that's equal to 343. Whoops, no it's not. I need to put 343 in the calculator. I'll have to do cube root 1/3 and then square that. Or I can put it in the calculator. 343 to the two-thirds power. I get 49. So x minus 12 is 49. To solve for x, I will add 12. And x is 62. Right? 49, 61. Wait a minute. Yeah, 61. That's why we do math in pencil. And I can check this. If I put 61 where the x is negative 1715 equal to negative 5 times 61 minus 12 to the 3 over 2 power. If I put this in the calculator, just like that, then I do negative 5 parentheses 61 minus 12 raised to the 3 divided by 2 power, and I get negative 1715. So it works out. I encourage you to check yourself when you do these It's just one more step at the end so that you can feel confident that what you did is right before you move on. Let's look at number 9. Number 9 is different from these. Number 9 has some things grouped together, but I only show the exponent on this n. So be careful with this. It isn't 5n with an exponent. It's 5 times n with an exponent. So when you isolate, you're only isolating this. So I need to move the 2 and the 5 first before I do my exponent reciprocal and solve. Go ahead and try this one. It's the same steps. These aren't complicated once you know what the rules are, and you work it out on your own. I'll work it out and we can compare and make sure that yours is correct. Okay. Not sure how we are with working together, or if I'm working ahead of you, or what's going on, but this is what I got. I got n is 100. Is that what you got? Okay, good. That's right. And you can, just like I said, you can plug this into for the n and check it. And it should work out and be true. So, you guys have some practice to do. And it may take some time to work through these. And then you'll have an exit ticket, which is some questions about the process. What would you do next? Is this one worked correctly? And have a couple for you to solve. So that exit ticket will be your daily grade for this lesson. And that'll be on Canvas, not on paper.